Okay, this says, what are all values of x for which the series converges? This is another way of saying what's the interval of convergence. Okay, so to find that, we do the ratio test. Remember, this is our a sub n. Okay, so we analyze this ratio. I'm going to be a little more succinct than in a previous video, rather. So, again, when you take the absolute value of the n plus first term, what you get is this. Okay, the x plus 3/2 has to be in absolute values to ensure it's positive. The absolute value of negative 1 to the n is just 1. And so there's my n plus first term in absolute value. And then we'll multiply by the reciprocal of the nth term. So the nth term almost looks the same, except we're n instead of n plus 1s. So now this will be on top here. Okay, and let's see, any canceling that can happen? Just a little, okay, so like that leaves one copy of x plus 3/2, and that's it. There's nothing else really we can do. So this ratio here equals absolute value of x plus 3/2 times n over n plus 1. Okay, and then the ratio test says take that limit, okay, as n goes to infinity. Anything that doesn't have an n can come outside. Oops, this should be absolute value. Anything that doesn't have an n can come outside, so you can start writing this, but you can then quickly just take out anything that doesn't involve an n. Okay, and you should recognize at a glance that that's 1, so that we get this, and according to the ratio test, we want that expression, whatever the result of the ratio test is, it has to be less than 1 to converge, which implies this, which minusing 3/2 from everything gives you negative 5/2 and then negative 1/2. Okay, so we can cross off a lot of choices here. Unfortunately, A, B, and C all have the numbers in column. It's the column, and it's the endpoints that we get to check. So this problem really is making us go the whole distance. So I'm going to copy down the series again. I got to check the endpoints though, right? So my series looks like this. Right, x plus 3/2 to the n, and I'm just going to replace. Okay, so when x is negative 5/2, let's see what we get. Then this becomes. I'll try to simplify a little along the way. So I get negative 1 to the n over n, negative 5/2 plus 3/2. Negative 5/2 plus 3/2 is negative 1. So I get negative 1 to the n. Okay, you can check that, right? All I'm saying is this becomes a negative 1, right? Now these can interact. Negative 1 to the n times negative 1 to the n is the same as negative 1 times negative 1 to the m. So, right, those combine to give you just 1 to the n, which is 1. So if I really find students, it's some of these little exponent properties, just a quick side note, right, that negative 1 to the n times negative 1 to the n, remember, is the same as -1 times -1 to the n. It's just undoing the power to the power rule, which is 1 to the n. That's why I made that a 1. Okay, but this diverges, which means -5 halves is out. So let's go see anyone that has -5 halves. So just see. All right, so we do have to check the other endpoint there, which is -1/2. Okay, so when n is, or when x is -1/2, okay, we get -1 to the n over n, and then -1/2 plus 3/2 is 1 to the n, which is just 1. So I end up with this. Now this converges conditionally. That should almost be instinctual. Okay, it doesn't converge absolutely, but it converges conditionally because 1 over n, the non-alternating part, is positive and decreasing to 0. That's basically all we need. And so we go put in an equal to there, we circle it, and then we notice that our answer choice is B. So that was a hefty one, but there it is.